Hello there, this is Haddad here. In this lecture, I'm going to explain to you about link state routing protocol. So we all know that we have IGP, Interior Gateway Protocol. And in IGP, we have two types of routing protocols. We have the distance vector and we have the link state. Okay. The distance vector route protocol is like, for example, RIP that I have already explained in another course on Udemy. And on Cisco, they have something called EIGRP. Actually, EIGRP is not said that it is a distance vector routing protocol. It's said in hybrid routing protocol. That means it takes the good from the link state and the good from the distance vector, and they combine it together. And then in this case, they made the EIGRP. Or they can sometimes call it an advanced distance vector, because distance vector routing protocol is a very old routing protocol, and it's not complex and doesn't have a lot of features. But EIGRP on Cisco is really a good routing protocol to be used, but the only problem on it is that it can be used only on the Cisco routers. That's why people go to OSPF, which is an open standard routing protocol. And link state, we have OSPF. Okay, so distance vector and link state routing protocols both are under IGP, Interior Gateway Protocol. That means routing protocol that we configure them inside our network. Okay, so inside our company, inside our hospital. Now, the difference between the routing protocols like the distance vector and the link state, for example, if we look to RIP, they send updates for the routing table every couple of seconds. For example, when you enable RIP, say on this network here, router 1 every couple of seconds, normally it's like 30 seconds, they send the routing table all to the routers which are connected to it. And so do also here and here. And this takes a lot of traffic on our network. And imagine that these routing tables are sent by broadcast if we use RIP version 1, or by multicast if we use RIP version 2. Okay, while on link state, it's different. Let me just give you an example. Imagine that we have this network here, router 1, 2, 3, 4, and 5, okay? And we need to configure link state routing protocol. For example, we need to configure OSPF. Okay? Then in this case, what will happen? We enable OSPF on router 1. So here I put O, means it's enabled. We enable here also OSPF on router 2, on router 3, and router 4, and on router 5. First of all, we need to know that OSPF has something called areas. That's something I'm going to explain to you later. So in this case, we have to have all those routers inside area. In this case, we have them inside area 0. That's something we will discuss about it later when we do speak about OSPF. But now I just want you to know the concept of link state to be able to understand how you can configure OSPF later. Now, we configured OSPF on all those routers. Directly, when we configure OSPF, the routers connect to each other, they will form neighbors to each other. Again, also we are going to speak about the neighbors and what are the criteria for the routers to form neighbors together. Okay, there are some criteria, but that's something we leave it for the upcoming lectures. Imagine now that there is neighbor between this and this router, and this. Okay, so it's both ways, huh? So that means like this. All routers, neighbor routers, they have formed neighborship between each other. Okay. After the neighborship is being formed between each other, what will happen here? Directly, the routers, for example, router 1, will start sending LSA. LSA means link state advertisement. Okay, I will write it just here to remember. LSA, that's link state advertisement. Okay. So what does it mean, link state advertisement? That means every one of this router on its port, which is connected to the neighbor, like for example here on Ethernet 1, it will send the link state advertisement, and the link state advertisement will say that this port, Ethernet 1, is connected to this network, okay, and it has a neighborship, or it is connected to the router 2. That's the link state coming from here. Same the router 2 do, that I am Ethernet 1 interface connected to this network, and I'm connected to router 1. Same do this here on this interface, router 1 and router 5, router 5 and router 4, and router 4 and router 3, and so forth. Okay, so every interface we say to where it is connected and the type of the interface for fast Ethernet or Ethernet or gigabit Ethernet, and what is the network connected to it, and then to which router is this connected. Okay, then they will exchange those LSA to each other, and then these LSA has to be flooded to all other routers which are inside our area, which is area 0.0.0.0. Okay, that means at the end, each of the routers will have the LSA of every other router, and we'll have the whole picture of the network. And that's what we call it, the link state database. Okay, so link state database. After every router collects the whole LSAs from all other routers, what they do, they put it like this is the LSA for all routers here and here and here. Okay. That means at the end what will happen, that every router knows how the network is connected, correct? And then they form what we call the link state database. Link state database. Every router. So every MikroTik router in this case will form something called link state database, and so forth for all other routers. Okay, then in this case every router has the full map of the network. Now what will happen is that every single router has to calculate the best route based on the link state database to be able to reach the destination. For example, router 1, say on router 3 here, there is a network 3.3.3.0/24, okay? Then router 1, based on the link state database he has over here, he will try to find out what is the best route to go to this network. Okay, again, based on what he has here from the link state database. Okay, let me just make it for you more clear here. Imagine yourself that you are traveling by your car, and you have your map on paper of the city where you are traveling. Okay, and imagine that you want to go from your place to another city. Then you open the map, and this map is the same that is for everyone else. Okay, you will look inside the map, and you see, okay, I'm on this point, I want to reach to that point. Then you will find out what is the shortest way to reach to that point from the place that you are based on, okay? Or for example, if you think of it like the navigator that you have in your car. When you're driving, you say that I want to go from where I am now to that destination. Then the navigator will start making the calculation based on what is the shortest path to be able to reach to that destination based on where you are now. Okay, same over here. Every router will, from his side, try to see what is the best path or the shortest path to be able to reach to the destination. And in this case, what will happen is that every router will issue something called OSPF algorithm, or this calculation, shortest path first calculation. And then this is based on an algorithm called Dijkstra algorithm. Dijkstra is the name of the person who created the shortest path first algorithm. Okay, we don't want to know how the OSPF works. It's not our responsibility to know that. It is automatically happening on the OSPF once you created the process of OSPF on the MikroTik routers. Okay, but just only to explain to you how it works. So again, a link state advertisement are being sent to all the routers. They all have link state database. Every router from his place will be running a shortest path algorithm based on Dijkstra algorithm to be able to reach to the destination. After this is done, they will take out one of the best route, and then they put it, every router they put inside the routing table. Okay, so they put what are the best. If each of those are routes, for example, you have another network here, which is 2.2.2.0/24. They will add here to reach 2.2.2.0/24, you have to go from, for example, this way, and to go to 3.3.3.0, you have to go from maybe from this way. Okay, but this is how normally link state works. All right, so it's a bit complex, but not really. If you only know it once, then it's easy to move forward with OSPF. Now, another thing to explain here is OSPF will require a lot of CPU usage, okay? Because as you can see here, they have to first send the advertisements, and then they have to make the LSDB. But then the most load that it is taking on the CPU of the router is when it has to do the OSPF algorithm. Okay, that's why we have divided this on areas. We are going to speak about areas in later when we speak about OSPF. But this is really what I wanted to explain to you about link state routing protocol. So this is how it works. And the routing table are not sent periodically like on a distance vector every 30 seconds. It doesn't do like this. Okay, what happens is whenever there is a failure, it will directly make process to find out another alternative way to reach the network which has the failure on its route. Okay, that's something we are going to speak about it in really large when I'm going to speak about OSPF. So this is what I wanted to show you in this lecture. Thanks you for watching, and till next time.